Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Circle Theorems practice questions. If you need any extra help on Circle Theorems, if you go to corbettmaths.com/contents and scroll down to video numbers 64 and 65, there's video tutorials there on Circle Theorems. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. So question number one. Question number one, we've been given this diagram and we're told that this is a circle and O is the center of the circle and the A, B and C are points on the circumference. And we're told the angle A, this angle, is 29 degrees and we've been asked to work out the size of angle B. So we want to find the size of this angle here. I'm just going to call that X for the moment. So we've got this triangle, and this triangle will be a right angle triangle. So whenever we've got this triangle inside of a semicircle, the angle at the top here would be a 90-degree angle. So that's a right angle triangle. So because we know this angle is 90 degrees, we've now got two of the angles inside of the triangle. We can add those together. So we can do 90 plus 29, and that's equal to 119 degrees. And then we can take it away from 180 to find the size of this angle. So 180 subtract 119 is equal to 61 degrees. So that means this angle, angle B, is 61 degrees. So 61 degrees. Okay, part B. Part B says A, B, C are 3 points on the circumference of another circle, and O is the center again of the circle. And we've got this angle, angle AOB, this angle is 112 degrees. And we've been asked to work out the size of angle ACB. So the angle at the circumference will be half of the angle at the center. So if we divide the 112 degrees by 2, we'll find the size of this angle. So 112 divided by 2. So whenever we do 112 divided by 2, so that'd be 56 degrees. So that means that this angle at the top here would be 56 degrees. So angle ACB is 56 degrees. So let's write that down, 56. Okay, let's have a look at our next question, question number 2. So question number 2 says points A, B, C and D are points on the circumference of a circle. And that means that this is a cyclic quadrilateral. It's a quadrilateral where all 4 points are on the circumference of a circle. And we've been asked to work out the size of angle DAB. So DAB, so that's this angle at the top here. So if we want to work out the size of this angle, when we've got a cyclic quadrilateral, the opposite angles add up to be 180 degrees. So if we take 62 degrees away from 180, we'll find the size of this angle, angle DAB. So if we do 180, take away 62, well, let's do that. 0 take away 2, let's borrow, so that's a 7 and a 10. 10 take away 2 is 8. 7 take away 6 is 1, and then 1. So that's 118 degrees. So that means that this angle is 118 degrees. So let's write that down. Angle DAB is 118 degrees. And then part B. Part B says work out the size of angle ABC. So that's ABC. We now want to find the size of this angle here. Now we could add together the 3 angles that we've got already, the 118, the 95 and the 62, and take those away from 360, and then we get the size of that angle. So that's one way we could work out the size of that angle. Alternatively, we could just look at the opposite angles. And remember, the opposite angles in a cyclic quadrilateral add together to be 180 degrees. So that means if we want to find the size of this angle, ABC, we just need to take 95 away from 180, and that'll tell us the size of this angle. So let's do that. So 180, subtract 95. So 0 take away 5, let's borrow. So 7 and a 10. 10 take away 5 is 5. And then we've got 17 take away 9, and that's 8. So that means the angle ABC is 85 degrees. So that means the size of this angle up here is 85 degrees. And that's it. So part A is 118 degrees and part B is 85 degrees. Okay, let's have a look at our next question, question number 3. So question number 3, we've got this circle, and we're told that O is the center of the circle, and the points A, B, and C are on the circumference of the circle. And then we're told that angle ABC, so angle ABC, this angle here is 20 degrees. And we've been asked to find the size of angle BAC, so BAC, so we want to find the size of this angle. Now, because we've got a triangle inside of a semicircle, that means that this is a right angle. So that's a 90-degree angle. So let's write 90 degrees there. And now we can just work out the size of this angle by doing 90 plus 20. 90 plus 20, that's equal to 110 degrees. And then if we take that away from 180, we can find the size of this angle. So 180 take away 110 is equal to 70. So it means that this angle is 70 degrees. So angle BAC is 70 degrees. Fantastic. Okay, let's have a look at our next question, question number 4. So question number 4 says points A, B, C and D are on the circumference of a circle, and we've been asked to find X, the size of angle ACD. So we want to find the size of this angle. So here we've got two angles in the same segment. We've got this angle and this angle. So if we look at points A and D, there's two lines going up from points A and D and they meet here at C. But also if we go back to A and D, two lines go up from A and D and they also meet at the point B. So it means that these two angles are the same size. So that means that X would be 50 degrees also. So that means that X is 50 degrees. And that's it. Okay, let's have a look at our next question, question number 5. So question number 5, it says in the diagram, O is the centre of the circle. We've got this diameter and then we've got this angle W, and we've been asked to write down the value of W. Because this is a triangle inside of a semicircle, this angle would be 90 degrees. It's a right angle. So that means that W is 90 degrees. Okay, question 5b. 5b, we've got this quadrilateral, the cyclic quadrilateral, because all of the points of the quadrilateral are on the circumference of the circle. So that means the opposite angles will add together to be 180 degrees. And we've been asked to work out the size of this angle. So if we do 180 subtract 116, that'll tell us the size of angle X. So let's borrow. So that's a 7 and a 10. 10 take away 6 is 4. 7 take away 1 is 6. And 1 take away 1 is 0. So that means that X is 64 degrees. So 64 plus 116 is 180 degrees. Fantastic. Okay, let's have a look at our next part, part C. So part C, we've been asked to find the size of angle Y here. Well, as you can see, we've got 2 points here and here, and then we've got 2 lines going up and meeting here. And then if we go back to those points, we've got 2 lines that go up and meet another point here. That means that these two angles are the same size. So it means that Y is 52 degrees. So 52 degrees. Okay, our next part, part D. Part D, we've got this diagram and we're told that O is the centre of the circle. So this angle, 88 degrees, is at the centre of the circle, and this angle Z is at the circumference of the circle, and the angle at the circumference will be half of the angle at the centre. So that means that if we do 88 divided by 2, that's equal to 44 degrees. So that means that this angle is 44 degrees. Fantastic. Okay, let's have a look at our next question, question number 6. Okay, let's have a look at question number 6. So question number 6 says that points P, Q, R, and S are 4 points on the circumference of a circle, and that PR, so the line PR, meets the line QS at the point A, so the point here where the two lines meet is A. And we're told that angle PRS is 57 degrees, so PRS is 57 degrees, and angle PAQ, that angle is 78 degrees. And we've been asked to work out the value of angle Y. So we want to find the size of this angle here and to include our method. Okay, so we want to find the size of this angle. Now to find the size of this angle, there's probably different approaches we could use here. But what I'm going to do is I'm going to first of all start by finding the size of this angle up here. This angle AQP or SQP, whatever you want to call it, this angle at the top here. Because we've got the points P and S, and we've got 2 lines that go up and meet at R, and then we've also got 2 lines that go up and meet at Q, these two angles will be the same size. So angle PRS is equal to angle SQP, and that's equal to 57 degrees. And that's because they're angles in the same segment. I'm just going to jot that down. Angles in the same segment are equal. And that's it. So the angles in the same segment are equal. So that's why angle PRS is the same as angle SQP. So that is 57 degrees. Now if you have a look here, we've got a triangle and the angles in a triangle. So we've got triangle AQP, and in that triangle the angles will add together to be 180 degrees. So if we do 57 plus 78, so 57 plus 78, that's equal to 50 plus 70 is 120, plus 7, 127, and then plus 8, 135. So they add together to be 135 degrees. If we then do 180 take away 135, that's equal to 45 degrees. So that means the angle Y is 45 degrees. So Y is equal to 45 degrees. And let's just explain that the angles in a triangle add to 180 degrees. So the angles in triangle AQP add to 180 degrees. I'm just giving the reasons as well as our method. So the question says work out the size of this angle. The angle is 45 degrees, and that's it, 45 degrees. Okay, let's have a look at our next question, question number 7. So question number 7 says the diagram shows points D, E, F, and G, on the circumference of a circle, and O is the centre of the circle, and we're told that EG is the diameter, so EG is the diameter of the circle, and that points D, E, F, and G form a kite. So D, E, F, and G form a kite. So because that's a kite, that means that EF is the line of symmetry, because a kite has one line of symmetry, a vertical line of symmetry, like so. So that means that if this is 65 degrees, the angle over here would be 65 degrees also. And then we've been asked to find the size of this this angle x. So if you have a look here on the left hand side, we've got a semicircle and we've got a triangle in a semicircle. So that means that that's a right angle, that's 90 degrees. That's 90 degrees. And the question says to work out the size of this angle x. So, well, if we just look at this triangle, we can add together the 65 degrees, the 90 degrees, and take that away from 180, and we'll find the size of that angle. So 65 plus 90 is equal to 155 degrees, and 180 take away 155 is equal to 25. So that means that x is 25 degrees, and that's it. Okay, let's have a look at our next question, question number 8. So question number 8 says the points A, B, C, and D are points on the circumference of a circle with centre O, and we've been asked to work out the size of angle BCD. So we want to find the size of angle BCD, so we want to find the size of that angle there. Now there's a few different ways in which you could approach this question. One approach is, because we know the size of the angle at the centre, we could half that to find the size of this angle here, the angle at the circumference, that angle. Then if we have a look at A, B, C, D, that's a quadrilateral, and the opposite angles in a quadrilateral add together to be 180 degrees. So we could then just take this answer away from 180 to find the size of that angle, angle BCD. So that's one approach we could use, and let's actually do that one to begin with. So let's half the 156 degrees. 156 degrees divided by 2 would be equal to 78. So that's 78 degrees. So that means that that angle there is 78 degrees. So that's my first step in my working out. I've worked out the size of angle BAD, so that's equal to angle BAD, and that's equal to 78 degrees, because the angle at the circumference is half the angle at the centre. Now we're going to find the size of angle BCD by considering this cyclic quadrilateral. So the opposite angles in a cyclic quadrilateral add together to be 180 degrees. So if we do 180 subtract 78, that's equal to 102 degrees. So angle BCD is equal to 102 degrees, and that's because the opposite angles in a cyclic quadrilateral add to 180 degrees. So let's write that. And that's it. So that means that this angle is 102 degrees. So that's it. So angle BCD is 102 degrees. Okay, that's one way we could have done that question. So that's one approach. So another approach we could have used is actually to find the size of this angle, this reflex angle. So we've got the size of this angle is 156 degrees. We could work out the size of the angle on the other side, that reflex angle, because the angles at a point add together to be 360 degrees. So if we do 360, take away 156, that's equal to 204 degrees. So that means that this angle on this side is 204 degrees. So the reflex angle, BOD, is 204 degrees because the angles at a point add to 360 degrees. Now if we have a look here, we've got an angle at the centre, the 204, and an angle at the circumference. So the angle at the circumference, this angle, will be half of this angle. So if we do 204 divided by 2, that's equal to 102. So that means that this angle is 102 degrees again. So that's another approach we could have used. We could have worked out the size of that reflex angle and halved it to find the size of the angle at the circumference. And although it looks slightly different than this one, where we halved the 156 to get 78 for that one, this looks slightly different because this is a reflex angle, but this angle at the circumference is still half the angle at the centre. So if we half the 204, we get the 102 there. So that means that that angle is 102. And that's it, so it's 102 degrees. And I've just written down the angle at the circumference is half of the angle at the centre. Now in this question, we were just asked to show our working, so we didn't need to give our full reasons, but quite often in circle theorem questions, you're asked to give your reasons. So I'm just going to give some reasons as we're going through here, just so that if you are asked to give reasons, you know what you should be given. Okay, let's have a look at our next question, question number 9. Okay, let's have a look at our next question, question number 9. So question number 9 says, AB is the diameter of a circle. So we've got the circle and we've got the diameter, AB. And we've been asked to work out the value of x. We want to find the size of this angle up here. Now, there's a few different approaches we could use for this question. There's two which I'm sort of seeing. I'm going to show you both approaches now. So my first approach I'm going to do is I'm going to look at the fact that this whole triangle is a right angle triangle because we've got the diameter. That means the whole angle up here would be 90 degrees. This whole angle up here is 90 degrees. Now, if this big triangle is a right angle triangle, that means that 90 plus 34 would give us the sum of those two angles. And then if we take them away from 180, we can find the size of this one. So let's do 90 plus 34. That's equal to 124. And then if we do 180, take away 124, that's equal to 56 degrees. So that means that this angle here is 56 degrees. So that angle there, angle ABC. Now, we want to find the size of this angle x. I'm just actually going to get my rubber and rub out that right angle. It's very big. and we want to find the size of this angle x. Now if we have a look here, we've got this smaller triangle and we've got two of the angles. So if we do 61 plus 56, that's equal to 117. And then if we do 180, take away 117, that'll give us the size of this angle, and that's going to be 63 degrees. So this angle at the top here is 63 degrees. So just to recap, we looked at the whole triangle, said that that was a right angle at the top. So that means we can work out the size of angle ABC is 56 degrees. Then we looked at this little triangle and used the 61 and the 56 to find that the size of the angle at the top would be 63 degrees. So that means that the angle is 63 degrees. So that's one way we could approach that question. I'm just going to change colour of ink to green and show you another approach. So what we could have done in this question is, rather than using the whole big right angle at the top to begin with, what we could have done as well, we looked here and there's a straight line. So that means the 61 and this angle add together to be 180 degrees. So if we do 180, take away 61, so that means that this angle is 119 degrees there. Then we've got this small triangle, so we can add these two angles together and take it away from 180 to find the size of the one at the top. So 34 plus the 119 would be equal to 153 degrees. So that means that these two angles, when you add them together, that's 153 degrees. Now we can take that away from 180 to find the size of that small angle at the top. So 180 take away 153 is equal to 27 degrees. So that angle at the top is 27 degrees. And then finally, now we can look at the big triangle and say, well, that's a right angle at the top. So if we do 90, take away 27, that's going to be equal to 63. So that means that this angle must be 63 degrees. And that's it. Okay, let's have a look at our next question, question number 10. Okay, so question number 10 says, the diagram shows a circle with center O. So this is the center of a circle, and we're told that points A, B, C are points on the circumference of the circle. And we're told the angle AOC, so AOC, that angle is 140 degrees. So we want to show the size of this angle is 110 degrees. So I'm just going to get rid of it for the minute, and let's find the size of this angle here. So we know that the angle AOC is 140 degrees. So the angles at a point add together to be 360 degrees. So if I take the 140 degrees away from 360, we can find the size of this reflex angle. So if we do 360, take away 140, that's equal to 220 degrees. So that means the angle, the reflex angle, AOC is 220 degrees. And let's explain that. The angles at a point add to 360 degrees. So that's the size of that angle. Now we want to show that this angle is 110 degrees. So remember, the angle at the circumference is half of the angle at the center. And remember, O is the center of the circle. So that means that if we half the 220 degrees, we'll find the size of that angle. So 220 degrees divided by 2 is equal to 110 degrees. So that means the angle ABC is equal to 110 degrees, because the angle at the circumference is half the angle at the center. So let's explain that. And that's it. So the question says, explain why angle ABC is 110 degrees. Well, the angles at a point add to 360 degrees. So that means that reflex angle AOC is equal to 220 degrees. And then if we do 220 degrees divided by 2, that's 110 degrees. And that means the angle ABC is 110 degrees, because the angle at the circumference is half of the angle at the center. And that's it. Okay, let's have a look at our next question, question number 11. So question number 11 says that Q and R are points on the circle center O, and that PQ and PR are tangents to the circle. And we've been asked to work out the size of angle POR, so POR. Okay, so let's draw some extra lines on this diagram. They will help us. So let's join the line joining O and R, so that radius, and let's join the radius from O to Q. So we've put those two radii on the diagram. And we've been asked to work out the size of angle POR. So I'm actually just going to join P and O together just so that we can see what that angle is. So that angle is angle POR. So we want to find the size of that angle there. Okay, so we want to find the size of this angle here. So a tangent and a radius will always meet at 90 degrees. So that will be a right angle. And here we've got another tangent and another radius, and they meet at 90 degrees. So we've got the radius and tangent, and they meet at 90 degrees. And we want to find the size of this angle. Now, the distance from P to Q will be the same as the distance from P to R. So that line's the same length as that line. Also, the radii are the same length as each other. So that means that this is a line of symmetry. The 44-degree angle has been chopped in half. So that means that that's 22 degrees there, and this is 22 degrees there. So if we have a look here, we've got a little triangle, POR, and the angles in triangle POR will add together to be 180 degrees. So we've got a 90-degree angle, a 22-degree angle, and if we add them together, 90 plus 22, that's equal to 112. And if we do 180, take away 112, that's equal to 68 degrees. So that means the angle X, or angle POR, that angle is 68 degrees. And that's it, 68 degrees. So in that question, just to recap, we know that the tangent and the radius met at 90 degrees. We know that if we join the point P to O, that we're chopping the 44-degree angle in half, so that's 22 degrees, and 90 plus 22 is 112, and when we take that away from 180, we get 68, so that's 68 degrees. Okay, let's look at our next question, question number 12. So question number 12, we've got this tangent, DAE, that's a tangent to a circle, and we've been asked to write down the size of angle ABC, so we want to find the size of this angle here. So we've got this tangent and we've got this triangle, and the angle between that tangent and the triangle here, this angle EAC, this angle, will be equal to the size of the opposite angle inside of the triangle. So if we go over to here, this angle is going to be 61 degrees. And that's what we call alternate segment theorem. Alternate segment theorem. And that alternate segment theorem says that the size of this angle, the angle between the tangent and the triangle, will be equal to the size of the opposite angle inside of the triangle. And likewise, if this is 63 degrees here, this angle over here would be 63 degrees. Not that we've been asked to write that one in, we've been asked to find the size of angle ABC, but angle ACB would be 63 degrees. And obviously, if we wanted to find the size of this angle, we know the angles in a straight line add up together to be 180 degrees, so we could work it out that way, or we could work it out the fact that we know that the three angles in a triangle add together to be 180 degrees. But anyway, the size of this angle is equal to the size of the opposite angle inside of the triangle, and that's alternate segment theorem. So the size of angle ABC is 61 degrees, so 61 degrees. Okay, let's have a look at our next question, question number 13. Okay, let's have a look at our next question, question number 13. So question number 13, we've got this circle, and we've got the points A, B, C, and D, which are points on the circumference of the circle, and we've got O, which is the center of the circle. And we're told that AOC is a straight line, so that's the diameter. And we're told the angle BAO, so BAO, that angle is 24 degrees, and angle ADO, so angle ADO is 42 degrees. And we've been asked to work out the size of angle CAD, so CAD. We want to work out the size of this angle here. Now in this question, there may be different ways to approach different parts of it. I'm just going to show you one approach, the approach that I probably would use for these questions. So if we start off by finding the size of this angle, so angle CAD, this angle here. Now if you notice, O is the center of the circle, and points A and D are points on the circumference of the circle. That means OA is a radius and OD is a radius. That means they're both the same length. So that line from there to there, and that line from there to there, the same length as each other. That means this is an isosceles triangle. So that means the angle CAD would also be 42 degrees, because the two angles here at the base of the isosceles triangle, if we turn our head sideways, we've got this isosceles triangle here. This side's the same length as this side, so that means that these two angles are the same as each other. So that means the angle CAD is 42 degrees. So let's write that down, 42 degrees. Part B says to find the size of angle ACB. So angle ACB. So we want to find the size of this angle here. So if I want to find the size of this angle, because I know that AC is the diameter, this is a triangle inside of a semicircle. So we've got this semicircle and this triangle. So that means that's a right angle. So that's 90 degrees. So if we want to work out the size of this angle here, I'm going to add together 24 degrees and 90 degrees, and then take that away from 180. So 90 plus 24 is equal to 114 degrees. And then 180 take away 114 is equal to 66 degrees. So that means the angle ACB is 66 degrees. And that's it. So let's write that down, 66 degrees. Okay, part C. Part C says to work out the size of angle BCD. So if we go up, we want to find the size of angle BCD. So angle BCD. So we want to find the size of this angle BCD. So the whole size of this angle here. Now, there's a few different ways we could do that. One approach is, well, we've got this triangle. We could work out the size of this angle. Then we've got a straight line, so we could work out the size of that angle. Then if that's the radius and that's the radius there as well, so that means that's an isosceles triangle. So once we find the size of this angle, we can then take it away from 180 and half it to find the size of this angle, and then add on 66. So that's one way we could do that. Alternatively, what we could do is we could look at this cyclic quadrilateral. So we've got the cyclic quadrilateral. So ABCD is a cyclic quadrilateral. That means the opposite angles in that quadrilateral add to 180 degrees. So if we've got angle BAD, this angle is equal to whatever 42 plus 24 is, that's 66 degrees actually. Then we know that the opposite angle, that whole BCD, this whole angle, if we take 66 away from 180, it'll give us the size of that angle. So let's do that. So 42 plus 24 is equal to 66 degrees. So that means that this angle is 66 degrees. So the opposite angle in the quadrilateral, the whole angle BCD, would be 180, take away 66, which is equal to 114 degrees. So that means the angle BCD is equal to 114 degrees. And that's it. As I've said, you could have done it a different way. We could have done it by finding the size of the little angle. So this would be 84. 180 take away 84 would be equal to 96. So that means that's a 96 degree angle. These two make a straight line. So 180 take away 96. 180 take away 96 would be equal to 84. So this angle up here is 84 degrees. If we take that away from 180, 180 take away 84 is equal to 96. And then if we half it, 96 divided by 2 is equal to 48. So that means that this angle is 48 and this angle over here is 48. And then if we add our 66 and a 48, we get that's equal to 114. So that's this angle. Angle BCD is 114 degrees. And you can approach that in either way. So angle BCD is 114 degrees. Okay, let's have a look at our next question, question number 14. So question number 14, we've got this circle and we're told that AOB is a straight line. AOB is a straight line. So that's a straight line. And that the points B and C are points on the circumference of the circle, center O, and the AC is a tangent to the circle. So AC is a tangent to the circle, and OC is a radius, so the tangent and the radius will meet at 90 degrees. So I'm going to put that 90 degree angle in there. And we've been asked to work out the size of angle Y. We want to work out the size of this angle here. Well, first of all, what I'm going to do is I'm going to find the size of this angle here, angle AOC. Because we've got a triangle, we know that's a 90 degree angle here, and that's 90 degrees. So if we do 46 plus 90, that's equal to 136 degrees. Then if we do 180, take away 136, that's equal to 44 degrees. So that means that this angle up here is 44 degrees, because the angles in a triangle add up to 180 degrees. Now we're going to work out the size of this angle here, and this is a straight line, so that means that if we do 180, take away 44, that's going to be the size of this angle. And 180 take away 44 would be 136. So that means that this angle is 136 degrees. Now we've got this triangle. We've got OB, which is a radius, and OC, which is a radius. So this is an isosceles triangle. So if we take our 136 away from 180, so 180 take away 136 is equal to 44. That means that these two angles add together to be 44. So if we then do 44 divided by 2, that's equal to 22 degrees. So that means that Y is 22 degrees. Now in this question, we weren't asked to give our reasons. We were just asked to work out the size of angle Y. That's 22 degrees. And that's it. So angle Y is 22 degrees. Okay, let's have a look at our next question. So our next question is question number 15. And we've got this circle, and we're told that shown as a circle center O, and the ABC is a straight line. So this is a straight line, and we're told the angle CBD is 146 degrees. So this angle here is 146 degrees. And the question says to work out the size of angle AOD. So AOD, and it's being marked with an X. So we want to find the size of that angle, AOD, this angle here. Now we're told that ABC is a straight line, so let's just go down. We're just asked to find the size of the angle. We're not been asked to give our reasons here. So we've been asked to find the size of this angle. So ABC is a straight line. So let's find the size of this angle here, angle ABD. So to find the size of angle ABD, what I'm going to do is I'm going to take the 146 degrees away from 180. So 180 take away 146 is equal to 34 degrees. So that means this angle is 34 degrees. Now we want to find the size of this angle. So we've got the angle at the circumference, so we want to find the angle at the center. So the angle at the center is double the angle at the circumference. So we do 34 multiplied by 2, that's going to be 68. So that means that this angle, AOD, is 68 degrees, and that's it, 68 degrees, and that's it. Okay, let's have a look at our next question, question number 16. So question number 16, we're told that RT is a tangent to the circle at the point S. So this is our tangent, RT, at the point S. And we've been asked to work out the value of X. We want to find the size of this angle, and we've been asked to give reasons for our answer. So we want to give reasons for this question. So at each step, we're going to give a reason as we're going through. So if we want to find the size of this angle, well, I'm looking at this and I notice we've got a tangent and then we've got this triangle. So I'm thinking of the alternate segment theorem, and the angle here between the tangent and the triangle will be equal to the opposite angle inside the triangle. So this angle here will be 42 degrees. So let's write that down. The angle SPQ will equal 42 degrees. And I've just written down the angle SPQ is 42 degrees, as is equal to angle QST due to alternate segment theorem, that angle is the same as that one because of alternate segment theorem. Now we've got a triangle and we know two of the angles, so we can just add these up and take them away from 180 degrees to find the size of angle PQS, which is the angle X that we're trying to find. So let's add these up and take it away from 180 degrees. So 42 plus 55 is equal to 97, and 180 take away 97 will be equal to 83. So that means that this angle is 83 degrees, and that's because the angles in triangle PQS add up to be 180 degrees. So let's write that down. And that's it. So I've just written down the angle PQS equals 83 degrees, as the angles in triangle PQS add together to be 180 degrees. So find the value of X, that's going to be 83 degrees. Okay, let's have a look at our next question, question number 17. So question number 17 says AC and BC are tangents to a circle with centre O. So this is a tangent and that's a tangent. And we've been asked to find the size of X. So we've got the size of this angle is X, and we've got the size of this angle is 4X. Now a tangent and a radius will meet at 90 degrees. So we can put a 90-degree angle in there and a 90-degree angle in there. And the angles in a quadrilateral, here we've got a quadrilateral, OACB, that's a four-sided shape, and the angles in a four-sided shape will add together to be 360 degrees. So that means that 4x, this angle, plus this angle, so plus x, plus 90 degrees plus 90 degrees, so adding up those four angles, that will be equal to 360 degrees. And that's an equation, we just need to solve it. 4x plus x is 5x's, and then we've got 90 plus 90, that's 180, and that's equal to 360. So that's our equation. So let's take away 180 and take away 180. So we get that 5x is equal to 180, because if we take away the 180 from the left hand side, we're left with 5x. And if we take away 180 from the right hand side, we're left with 180. And then finally, we just need to divide by 5 and divide by 5. 5x divided by 5 would just be x, or 1x, and then 180 divided by 5 is 36. So that means that x is 36 degrees. So that means that this is a 36-degree angle. And if you were asked to work out the size of this one, we would do 36 times 4, and that would be the size of that angle. Okay, let's have a look at our next question. Okay, let's have a look at our next question, question number 18. And question number 18 looks quite complicated, but let's have a look at it. Q, R, S, and T. So Q, R, S, and T are points on the circumference of a circle, centre O. And we know some of the angles. We know that this angle, ROT, is 110 degrees. We know the angle PTQ is 103 degrees. And we've been asked to find the size of angle RPS, so RPS, which is marked with a Y. So we want to find the size of this angle. And we're also told that PQR is a straight line and PTS is a straight line. And we've been asked to show all our working. So let's find the size of this angle. So what I'm actually going to do is I'm just going to fill in some of the angles on this diagram to begin with. And then once we fill in some of the angles on the diagram, then what I'll do is once we can work out the size of this angle, we'll go through and give our reasons. Now the question just says to show our working out, but I'm going to give reasons as we go through. So here we've got that this angle is 110 degrees. Now the angles at a point add together to be 360. So if this angle is 110, the reflex angle beneath it will be 250 degrees. So that angle is 250 degrees. Now we know the size of that angle is 250 degrees. The angle at the circumference will be half of the angle at the centre. So if this angle is 250 degrees, this angle up here will be half of it. And 250, so we'll do 360 take away 210 to begin with, that's 250. That's the size of that angle. The size of this angle, we'll do 250 divided by 2, and 250 divided by 2 is 125. So this angle here is 125 degrees. So we've now got the size of this angle here, angle RQT. And now we were told that the line PQR is a straight line. So that means this is a straight line. So if this is 125 degrees, if I want to find the size of this angle, the angle PQT, I'm going to do 180 take away 125, because these two angles must add together to be 180 degrees, and that's 55 degrees. So that means that this angle is 55 degrees. That's fantastic. We're left with a triangle. The triangle is PQT, and these three angles will add together to be 180 degrees. So let's add the two that we know, the 103 plus 55, that's equal to 158, and then if we do 180, take away 158, and that's equal to 22 degrees. So that means the angle Y is 22 degrees. So we've done it. So the question says to show our workings. We've shown our workings and that's it. So the size of angle RPS is 22 degrees and that's it. Now in this question, if it didn't say show your work and it says give your reasons, then you would write down full reasons. And what I would say is, and that's it. So if we were asked to give reasons instead of just our working out, then I would have written down that reflex angle ROT is equal to 250 degrees because the angles at a point add to 360 degrees. I would then say the angle RQT is 125 degrees because the angle at the center is double the angle at the circumference. I would then say the angle PQT is 55 degrees because the angles in a straight line add up to 180 degrees. And finally, I would say the angle RPS is equal to 22 degrees because the angles in a triangle add to 180 degrees. And that's what I would say if I was asked to give reasons. But in this question, it just said to show your working, so that would have been enough on the right-hand side. Okay, let's have a look at our next question. Okay, let's have a look at our next question, question number 19. So question number 19, we're told that A, B and C are points on the circumference of a circle with centre O. And we're told that AOB is the diameter of the circle, and that CD and BD are tangents to the circle, and the angle CDO is equal to 29 degrees. And then the question says, work out the size of angle AOC. So we want to find the size of this angle here. I'm just going to mark it X. And we've been asked to give reasons for each stage of our working. Okay, so let's fill in the numbers that we can to begin with, and let's talk about it, and then we'll write down our full reasons afterwards. So we were told that BD and CD are tangents. That means the radius and the tangent will meet at 90 degrees. So that's a right angle, and that's a right angle. Now we know that this angle is 29 degrees and this one is 90 degrees. So the angles in a triangle add up to 180 degrees. So if we do 90 plus 29, that's equal to 119 degrees. And if we take that away from 180, we can find the size of this angle here. So 180 take away 119 is equal to 61 degrees. So this is a 61 degree angle there. Now another point to notice is that if we have this tangent CD and we've got this tangent BD, they will be the same length as each other because the length of the tangents from one point will be the same length. So that length is the same as that length. And here we've got a radius and a radius, so there we've got two radii, so they're the same length as each other. So that means that this is a kite, and it means that this is a line of symmetry of the kite. OD is a line of symmetry, so that means that this is a 29 degree angle as well. Now again, we've got the same triangle with that 90 degree angle, so that means that again this angle here would be 61 degrees because 90 plus 29 is 119. I'm taking it away from 180 would leave us with 61. Now we've got this straight line AOB, and the angles in a straight line will add up together to be 180 degrees. So if we do 61 plus 61, that's equal to 122. And then if we take that away from 180, so 180 take away 122, that's equal to 58 degrees. So that means that this angle is 58 degrees, and that's it. So angle AOC is 58 degrees. So let's write that down, 58 degrees. Okay, now in this question we're asked to give reasons for each stage of our working, so let's do that. So let's go through the steps that we did, okay? So the first thing we said that these were right angles. So we've just written down that angles OCD and ODB are 90 degrees. They're both right angles, and let's give the reason. And the reason is that a tangent and a radius meet at 90 degrees. So that's our first step. The next step, we worked out the size of this angle. We worked out the size of angle COD was 61 degrees. So let's write that down because the angles in a triangle add up to 180 degrees. So let's write that down. Angle COD equaled 61 degrees. So we've done that part. The next thing we done was we said that angle ODB and angle CDO were both the same. So we said that they're both 29 degrees because this is a kite. So let's write that down. And that was a line of symmetry, so they're the same as each other. So I've just written down that angle CDO and angle ODB were both 29 degrees as OCDB is a kite as it's got two tangents and two radii. So it's a kite. Okay, and then we worked out the size of angle DOB, and DOB was 61 degrees as well. So angle DOB is equal to 61 degrees as the angles in a triangle add up to 180 degrees. So I've just written down that angle DOB equals 61 degrees as the angles in a triangle add up to 180 degrees. And then finally, we found out that angle AOC equaled 58 degrees as the angles in a straight line. We had this straight line, and the angles in a straight line add up to 180 degrees. So that means that angle AOC is 58 degrees. And that's it. So they're the reasons that I've given for that question. Now, whenever you're doing a question like this, you may have done things in a slightly different order, but that's how I approached it. And we found the size of angle AOC was 58 degrees. Okay, let's have a look at our next question, question number 20. Okay, so question number 20 says, DEFG is a cyclic quadrilateral. Okay, so the opposite angles add up to 180 degrees. We're told that PDQ is a tangent at D, and we're told that O is the center of the circle, and that DEF is an isosceles triangle. So we've got DEF and it's isosceles. And part A says work out the value of A. So we want to work out the value of A. So if we have a look at the cyclic quadrilateral DEFG, the opposite angles will add to 180 degrees. So if we do 180, take away 82, that's equal to 98. So that means that A is 98 degrees. So A is 98 degrees. Part B says work out the value of B. So if we have a look, we want to find the size of this angle here. So if you have a look here, we've got this triangle. We've got triangle DEF. There's a triangle, and we've got the angle between the tangent and the triangle. So that's alternate segment theorem, and that angle will be the same as the size of that angle there, the opposite angle inside of the triangle. Now this is an isosceles triangle. We were told that in the question. DEF is isosceles, and we've got the two little lines to help us. So let's find the size of these two angles. So if we do 180 degrees, take away 82 degrees, that's equal to 98 degrees. And then if we take our 98 degrees and divide by 2, that's 49 degrees. So that means that this angle is 49 degrees. That means that that angle is 49 degrees. And because of alternate segment theorem, that angle will be the same size as that angle. So that's 49 degrees as well. So B is 49 degrees. And part C says, what's the name of the circle theorem we used? Alternate segment theorem. Alternate segment theorem. And that's it. Okay, let's have a look at our next question, question number 21. So we've got this circle, and O is the center of the circle, and B, C, and D are points on the circumference of the circle. And we're told that ABO is a straight line, so this is a straight line. We're told that AC is a tangent to the circle, so AC is a tangent, so that means that's going to be a 90-degree angle. And if we carry on, we've been asked to work out the size of angle AOC. So we want to find the size of angle AOC. So we want to find the size of that angle. Well, actually, because that tangent and the radius meet at 90 degrees, we've got this right angle triangle. So triangle AOC is a right angle triangle. We know one of the angles is 32 degrees. We know this one's 90 degrees. 32 plus 90 is equal to 122 degrees. And if we take that away from 180, we can find the size of that angle. So 180 take away 122 is equal to 58 degrees. So it means that this angle up here is 58 degrees. So that's 58 degrees. Okay, let's have a look at our next part, part B. Part B says work out the size of angle BDC. So we want to find the size of this angle. Now we could try and find these angles and help us find this one here, but what I'm actually going to do is I'm actually just going to look at this one and look at the center, because if I'm going to draw a little sketch here, and please excuse it, it's not perfect. So if that was the center of the circle, and we had a line going there and a line going there to the two radii, and we went up to perhaps a point over here somewhere, the angle at the circumference would be half of the angle at the center. Now, if we move this point around to perhaps instead of being up here down to here, it would look something like what we've got here, where we've got the angle at the center and the angle at the circumference. So this angle is half of this angle. And there's some great websites you can go to online, and you can have a look at this, an interactive version of this, where you could have this and just move this point around, and you can see that this angle will stay the same. So that means that here we've got this angle is 58 degrees. This angle would be half of it, which is 29 degrees. So angle BDC is 29 degrees, and the reason is the angle at the circumference is half of the angle at the center, and it doesn't matter if we move that point around from up here down to there, as long as B and C, the lines are still coming from B and C, the angle at the circumference will still be half of the angle at the center. So that's 29 degrees. So let's write that down, 29 degrees. Okay, so we've done part B. Now let's have a look at part C. So part C says work out the size of angle ACD. So ACD. So we want to find the size of this whole angle here. So if this part's 90 degrees, if we can find the size of that angle, then that means that we can then add them together to find the size of angle ACD. So let's find the size of this angle. So here we've got two parallel lines, and if this line's going straight up, it's 90 degrees. That means that this would be a right angle as well. And here we've got two lines that cross each other, and the vertically opposite angles are equal. So if that's a right angle, this is also a right angle. So this is a right angle triangle. And we know that this angle is 29 degrees. So if we do 90 plus 29, that's equal to 119 degrees. And then if we take that away from 180, we can find the size of this angle. So 180 take away 119 is equal to 61. So this angle is 61 degrees. So that means that if we want to find the size of angle ACD, which we do, we need to do 90 plus 61, and then that will tell us the size of that angle. So 90 plus 61 is equal to 151 degrees. So the angle ACD is 151 degrees, and that's it. Okay, let's have a look at our next question, question number 22. So question number 22, we're told that PQRS is a cyclic quadrilateral. We're told that APB, so APB is a tangent to the circle at P. We're told that PQ is parallel to RS, so this line is parallel to this line. You can see that with the arrows. And we're told that angle SPB, so angle PB is 35 degrees, and angle PSQ, so PSQ is 80 degrees. And we've been asked to find the size of angle QRS in part A, so QRS, that's marked with an A, so we want to find the size of this angle here. Okay, if I want to find the size of this angle, now we've not been asked to give reasons, so we can just work it out. So having a look at this diagram, the first thing that I notice is that we have got this triangle. We've got this triangle PQS, and we've got the angle between the tangent and that triangle. So this angle will be equal to the opposite angle inside of the triangle. So this angle here is going to be 35 degrees, and that's alternate segment theorem. The angle between the triangle and the tangent is equal to the opposite angle inside of the triangle. So that angle there would be 35 degrees. Now we want to find the size of this angle. We were told it was a cyclic quadrilateral, so if we can find the size of this angle, then we can if we know the size of this angle, we then know that the opposite angles in a cyclic quadrilateral add together to be 180 degrees. So let's find the size of this angle here. So we've got 35 degrees and 80 degrees, so 35 plus 80 is equal to 115 degrees, and then 180 take away 115 is equal to 65 degrees. So this angle here is 65 degrees. Now we know the size of this angle. Because PQRS is a cyclic quadrilateral, the opposite angles in a cyclic quadrilateral add together to be 180 degrees. So if we take 65 away from 180, we get A. So 180 take away 65, using what we've done before, that's going to be equal to 115 degrees. So that means that A is 115 degrees. 115 degrees. Part B says to work out the size of angle RQS, and I'm guessing that's been marked with a B on the diagram for us. Yep, RQS. We want to find the size of this angle here. And we've been told that PQ and SR are parallel lines. So this line is parallel to this line. And we've got this straight line that crosses through them. So that means that we've got this alternate angle. This, some people call it Z angle, but this angle is going to be the same as this one. These are alternate angles to each other, because if you turn your head sideways, you've got the parallel line. This angle is going to be the same as this angle. So that means that this angle is 35 degrees. And we also know that A was already 115 degrees. So we can now work out the size of B. So if we add these two angles together, 115 plus 35 degrees, that's equal to 150 degrees. And then 180, the angles in a triangle, take away 150, that's equal to 30 degrees. So that means that B is 30 degrees. And that's it. So B is 30 degrees. Okay, let's have a look at our next question, question number 23. So question number 23, we've been given this diagram and we've got the points O, which is the centre of the circle, A, C and B, which are points on the circumference of the circle. We're told that BCQ is a straight line and the lines AB and OC cross at the points P. And we've been asked to work out the size of angle OCQ. So OCQ, that's the size of this angle here. So we want to find the size of that angle there. Now we know that OC is a radius. And if that's a radius, it means it's a straight line. So that means that if this is 94 degrees, this 94 degrees and this angle here will add together to be 180 degrees because OPC is a straight line. So let's take 94 degrees away from 180 degrees to find the size of this angle. So if we do 180 degrees, take away 94 degrees, that's equal to 86 degrees. So that means that this angle is 86 degrees. And let's write that down. The angle BPC, angle BPC is equal to 86 degrees as the angles on a straight line, because the angles on a straight line add to 180 degrees. Fantastic. Okay, next. Now we want to find, ideally, because we want to find the size of this angle, it'd be great if we could even find the size of this angle or this angle here. Now if we have a look here, we have got the points A and C, and we've got two lines that go up and meet at the centre of the circle, and we've got two lines that go and meet at the circumference of the circle. So if we look at this angle and this angle, so angles AOC and angles ABC, the angle at the circumference is going to be half the angle at the centre. And earlier on in this video, we looked at a question like that, where the angle at the circumference wasn't just directly above the angle at the centre. So this angle is going to be half of this angle. So that means if we do 58 divided by 2, that's equal to 29 degrees. So this angle is 29 degrees. And let's explain that. The angle ABC is equal to 29 degrees. And that's it. So we just said the angle ABC is 29 degrees because the angle at the circumference is half the angle at the centre. Now this is great because we've now got this triangle. We can find the size of this missing angle, angle BCP, by just doing 86 plus 29 and taking that away from 180 to find the size of that angle. And then we can get that answer and take it away from 180 to find the size of angle OCQ. So let's do that. So 86 plus 29 is equal to 115 degrees, and 180 take away 115 is equal to 65 degrees. So this angle here is 65 degrees. So let's write that down. angle OCB equals 65 degrees, as the angles in a triangle add to 180 degrees. And finally, we'll want to find the size of angle OCQ. So we just need to take that away from 180. We just need to take 65 away from 180. So 180 take away 65 is equal to 115 degrees. So that means this angle is 115 degrees. And again, let's give our reason. Angle OCQ is equal to 115 degrees, as the angles in a straight line add to 180 degrees. And that's it. Okay, let's have a look at our next question. Question number 24, and we're told that EFGH are points on the circumference of a circle, centre O. And we're told the angle OHG is 31 degrees, and angle EGH is 48 degrees. So angle EGH is 48 degrees. So we've got these two angles, and we've been asked to work out the size of angle EFG. So EFG, the size of that angle, and we've been asked to give reasons for each stage of our working. So let's do that. Okay, so we want to find the size of this angle, so let's find some of the missing angles on this diagram to begin with. So what I notice, if I look at EGHO, we've got the angle at the centre and the angle at the circumference, and the angle at the centre is double the angle at the circumference. So if we do 48 multiplied by 2, that's equal to 96 degrees. So this angle is 96 degrees, and we've been asked to give reasons for each stage of our working, so let's write that down. Angle EOH equals 96 degrees, as the angle at the centre is double the angle at the circumference. Okay, so we've done that first bit. Now if we have a look here, we've got OE and OH. OE and OH will both be radii. They're both radiuses, both radii. So OH is a radius and OE is a radius. That means they're the same length as each other. So that means the triangle OEH is an isosceles triangle. So we can work out the size of this angle. And if we can work out the size of this angle, we can then look at the cyclic quadrilateral. So let's find the size of angle OHE. So we'll do 180 subtract 96, that's equal to 84, and then if we do 84 divided by 2, that's equal to 42 degrees. So this is a 42 degree angle. So that means the angle OHE is equal to 42 degrees, as triangle OHE is isosceles. Okay, so we've now worked out the size of angle OHG and OHE. So that means that GHE, that whole angle, angle GHE, will be equal to 31 plus 42, which is 73 degrees. 73 degrees. So I'm just going to write down the angle GHE equals angle OHG plus angle OHE, so that those two angles add together to form the whole thing. And then finally, we want to find the size of this angle. We have got this cyclic quadrilateral, and because this is a cyclic quadrilateral, the opposite angles will add to 180 degrees. So our 73 degrees and this angle over here, the one we're trying to find, will add together to be 180 degrees. So if we do 180 subtract 73, that's equal to 107 degrees. So that means that this angle is 107 degrees, and that's it. So our angle is 107 degrees, and let's just write that last step, that angle EFG equals 107 degrees, as the opposite angles in a cyclic quadrilateral add to 180 degrees. And that's it. Okay, let's have a look at our next question. So question number 25. So question number 25, we've got this circle and we've got the cyclic quadrilateral, and we've got some angles marked on W, Y, X and Z, or W, X, Y, Z, and we're told the ratio of angle W to X is 5 to 7, and the ratio of X to Y is 3 to 2, and we've been asked to find the size of angle Z. So we want to find the size of this angle. Now we're told the ratio of angle W to X is 5 to 7, but we know that these two angles add together to be 180 degrees, because the opposite angles in a cyclic quadrilateral add to 180 degrees. So if we can share 180 degrees in the ratio of 5 to 7, we can find the size of each of these angles. So let's do that. So let's add together the parts in the ratio. 5 plus 7 is equal to 12, so it's 12 parts altogether. And if we do 180 divided by 12, that's equal to 15. So that means that in each part there's 15 degrees. Now the angle labelled W, it's got 5 parts, so 5 times 15 is equal to 75 degrees. That means that W is 75 degrees. And X is the 7 in the ratio, so 7 lots of 5 is equal to 105 degrees. So that means that X is 105 degrees. So we found the size of those two angles. Now we're also told the ratio of angle X to angle Y is 3 to 2. So that means if this is 3 in the ratio, this is 2 in the ratio. So if we want to find the size of angle y, we just need to divide the 105 by 3, the x number in the ratio, so 105 divided by 3 is equal to 35 degrees, and then multiply by the y number in the ratio, which is 2. So 35 times 2 is equal to 70 degrees. So that means that x is 70 degrees. So that's fantastic. We found 3 of the angles, but now we could just take these away from 360 to find z, and that's going to be 110. Alternatively, the opposite angles in a cyclic quadrilateral add to 180 degrees, so you could just do 180, take away 70, and that's 110 degrees also. So that's 110 degrees, and that's it. So the size of angle z is 110 degrees, and that's it. Okay, let's have a look at our next question, question number 26. So question number 26 is a calculator question, and we've got P, Q, O, R, and we're told that Q and R are points on the circumference of the circle, centre O, and we're told that PQ and PR are tangents to the circle. Now, because both tangents start at the point P, that means they're the same length as each other. So if this is 30 centimetres, that is 30 centimetres also. And we're told that PR is 30 centimetres, and we're told that OP is 34 centimetres, and we've been asked to calculate the length of OQ. So we want to find the length of OQ. We want to find this length here. Let's just call X. Now, because this is a tangent and this is a radius, that's going to be a right angle, because a tangent and a radius meet at 90 degrees. So we've got a right angle triangle, and we know 2 of the sides, and we want to find the length of the third one. So we're going to use Pythagoras' theorem. So remember, Pythagoras' theorem is a squared plus b squared equals c squared. And let's label our sides. A and B are the 2 shorter sides, and C is the hypotenuse, the longest side. So let's start off with the hypotenuse. If this is the right angle, the hypotenuse will be opposite it. So the 34 centimetres is the hypotenuse, and A and B are the 2 shorter sides, A and B. And it doesn't matter which way around you label those. So instead of A squared, we've got X squared plus, and then we've got B squared, which is 30 squared, is equal to 34 squared. Now it's great, it's a calculator question, so x squared plus, and 30 squared is 900, and then we've got that's equal to, and 34 squared is equal to, 1156. So we've now got this equation, and we want to solve it. So we've got that x squared plus 900 is 1156. I'm just going to write that out a bit more tidily. So let's now take away 900 from both sides of the equation. So we take away 900 and take away 900, we get the x squared on the left hand side is equal to, and 1156 take away 900 is equal to 256. So that means the length of this side squared is 256. Now it's obviously not 256 centimetres, so we now need to square root. So x will be equal to the square root of 256, and the square root of 256 is equal to 16. So x is equal to 16 centimetres. So that means that OQ is 16 centimetres long. So let's write that down. The OQ is 16 centimetres. Okay, and part B. Part B says to calculate the circumference of the circle. So circumference is pi times diameter. So the circumference is equal to pi times diameter. That will give us the circumference of the circle. Now, if we have a look, we've just worked out the radius. The radius is 16 centimetres. Now, the diameter, the whole way across the circle, will be double the radius. So that means the diameter is equal to 32 centimetres. So to find the circumference, we're going to do pi times 32. And pi times 32 would be 32 pi. It's a calculator question, so let's work that out. That's equal to 100.5309 and so on centimetres. Now, did the question tell us to give it so many decimal places? 1 decimal place. So it's going to be 100.5 centimetres to 1 decimal place. So 100.5 centimetres. And that's it. Okay, let's have a look at our next question, question number 27. So question number 27 says, B, D, and E are points on the circumference of a circle, and the AC is the tangent to the circle at the point B. And we're told that angle DBE is 2x, and angle CBE is x plus 15 degrees. And we've been asked to work out the size of angle ABD, so we want to find the size of this angle over here. Now here we've got some algebraic expressions for the size of the angles. So there may be an equation that we're going to form to solve that to find out what x is. So let's have a look and see if we can do that. So here we've got a triangle inside of the circle and a tangent, and the angle between the triangle and the tangent, this angle, will be equal to the size of the opposite angle inside of the triangle. So if this angle is x plus 15, this angle up here will be x plus 15 degrees. So that's the size of that angle. Now this triangle, if we have a look at it, is an isosceles triangle. We've got our 2 little dashes that show us that the line DE is the same length as the line BD. So that means this is an isosceles triangle. So that means that the 2 angles at the base, the 2x and the 2x up here, will be the same as each other. So these 2 angles are the same. So that's fantastic. We've now got expressions for each of the 3 angles. We can add them together and put it equal to 180 degrees and solve that and find out what x is. So let's do that. So let's add them together. So we'd have 2x plus 2x plus x plus 15, and that's equal to 180 degrees because it's a triangle. 2x plus 2x is 4x plus x is 5x. So we've got 5x plus 15 is equal to 180 degrees. Now let's take away 15 and take away 15, and we'll get that 5x is equal to 165 degrees. And then if we divide by 5 and divide by 5, we're going to get that x is equal to 33 degrees. So that means that x is 33 degrees. So if we go back up, we know that x is equal to 33 degrees. So that means that this angle would be double x. That's going to be 66 degrees. This angle would be 66 degrees. This angle over here would be 33 plus 15 is 48 degrees. And this angle is 48 degrees also. Now the question asks us to work out the size of an angle ABD. So we were trying to find the size of that angle. Well, we've got a straight line here, and we've got two of the angles. We've got 66 degrees and 48 degrees. So if we add them together and take them away from 180, we can find the size of that angle. So 66 plus 48 would be equal to 114 degrees. So 114 degrees. And then if we do 180, take away 114, that's equal to 66 degrees. So that means the angle ABD is 66 degrees. And that's it. Okay, let's have a look at our next question, question number 28. It's a calculator question, and we've got this circle, and we've got what looks like a triangle, and we're told that B is a point on the circumference of a circle, center O. We're told that AB is a tangent to the circle, and we're told that OA is equal to 14 centimeters, and the OB, which is the radius, is equal to 3 centimeters. And we've been asked to work out the size of angle AOB, so we want to find the size of angle AOB. Now here we've got a tangent and a radius, so they'll meet at 90 degrees, so that's a right angle. And we've got a right angle triangle, and we know the lengths of two sides, and we're trying to find the size of one of the angles. So that's going to be a trigonometry question. So let's write down our trigonometric ratios. They are that the tan is equal to, the tan of an angle is equal to the opposite divided by the adjacent, 2 old angels. Skipped over heaven, so sine is equal to opposite over hypotenuse, skipped over heaven. Carrying a harp, cos x is equal to the adjacent divided by hypotenuse. So 2 old angels skipped over heaven carrying a harp, or however you may want to remember it. So they are our trigonometric ratios, and let's label the sides of this right angle triangle. So here's the right angle. So the side opposite the right angle will be the hypotenuse. So that means that OA is the hypotenuse, so that's H, capital H. The angle we're trying to find is this angle here. Let's call that beta. The side opposite will be the opposite. So that means that AB is the opposite. And that means the side we've got left, this OB, this radius, is the adjacent. Now in this question, we've been given the hypotenuse and we've been given the adjacent. And we're not trying to find, and we're not being given the opposite, so we can cross that off. So we can cross off any trigonometric ratio that has the opposite. So we're not using tan and we're not using sine. So in this question, we're going to be using the cosine, or the cos of the angle. So let's write that down. That the cos of the angle, now I've called the angle beta, so the cos of beta is equal to the adjacent, which is 3, divided by the hypotenuse, which is 14. So the cos of this angle is equal to 3/14. Now 3/14 is obviously a decimal number, 0 point something, and this angle obviously isn't 0 point something degrees. So we want to find the angle, so we're going to need to do the inverse cos. And if we do the inverse cos, we're going to get that theta is equal to the inverse cos, or the cos with a little -1, and then we're going to do the inverse cos of 3/14. So on our calculator, we'll press shift and then cos, and then the fraction button, 3/14, and then press equals, and that gives us that theta is equal to 77.626 and so on degrees. And if we round that to 2 decimal places, that means that theta would be 77.63 degrees to 2 decimal places. So we've found the size of angle AOB, that's 77.63 degrees, and that's it. Okay, let's have a look at our last question, question number 29. So question number 29, we've got the circle, and we're told that A and B are points on the circumference of the circle, centre O. We're told that CA is a tangent to the circle, and we're told that angle CAB is equal to 2x. And we've been asked to prove that angle AOB, so this angle, is equal to 4x. So we want to prove this angle is equal to 4x. And we've been asked to give reasons for each stage of our working out. Okay, so let's have a look at this. Okay, so the first thing that I notice is we've got a tangent and we've got this radius. So that means that this angle OAC, this whole angle, is a right angle. So let's write that down. The angle OAC is equal to 90 degrees. And we've been asked to give reasons because a tangent and radius meet at 90 degrees. So that means the angle OAC, that whole angle, is 90 degrees. Now we know the angle BAC, this angle is 2x. So if we wanted to find the size of this little angle in here, I could take 2x away from 90 degrees to find the size of this one. So this would be 90 minus 2x. So let's write that down. The angle OAB is equal to 90 minus 2x. Okay, so we've now worked out the size of that angle. Now another thing that I notice is we've got OA and OB. So that means that this is an isosceles triangle. That length is the same as that length. Let's write that down. That OA equals OB because they're both the radius. So therefore, triangle OAB is isosceles. So that means that this is an isosceles triangle. And if this is an isosceles triangle, that means the angle up here at the top here would also be equal to 90 minus 2x. This angle at the top here. So let's write that down. The angle OBA is equal to 90 minus 2x degrees, as triangle OAB is isosceles. And that's fantastic. So we now know the size of this angle is 90 minus 2x, and we've got a triangle and we know the size of two of the angles. Now we've been asked to show that this angle is 4x. So I'm just going to let this angle be called y for the moment, and I know that these three angles must add together to be 180 degrees. So let's write that down. That y plus 90 minus 2x, just going to put that in brackets, plus 90 minus 2x must be equal to 180 degrees. Now obviously if you were doing this, maybe you write it down below so you've got a bit more space. So we've got an equation here and we want to find out what y is, and hopefully we're going to see that it's equal to 4x. So let's do that. So let's simplify this. So we've got y, and then we've got plus 90, so that's going to be plus 180. And then we've got minus 2x, take away over 2x, that's going to be minus 4x. And then we've got that's equal to 180 degrees. Now we want to solve this, so we want to get the y on its own, we want to find out what size this angle is. So what I'm going to do is I'm going to add 4x to both sides of this equation. So add 4x and add 4x to get rid of the x's on the left hand side. So on the left hand side we'll be left with y plus 180 degrees, and on the right hand side we had 180 degrees and we're adding 4x, so plus 4x. So we've now got that y plus 180 is equal to 180 plus 4x. Now we want the y on its own, so let's take away 180 and take away 180. And when we do that, on the left hand side we'll be left with y, and on the right hand side we had 180 plus 4x. We're taking away the 180, so we've got that's equal to 4x. So that means that y would have to be equal to 4x. And so that means that y is equal to 4x, and that's it. So y is equal to 4x. We've shown it, and we've just proved it. So let's just write down our last step. So we said that angle OAB plus angle OBA plus angle AOB, they all add together to be 180 degrees. So therefore, angle AOB equals 4x, and we've got our working out here to show that, and that's it. So that we've shown it. So let's put QED, we've proved it, and that's it. And we could check our answer. If we had these angles in the triangle, 90 minus 2x, 90 minus 2x, if we add them together we get 180 minus 4x. So this would have to be 4x so that we get 180 degrees altogether, and that's it. So we've been asked to prove that angle AOB is 4x, and we've done that, and that's it. So that's it. So these have been the video solutions to the Circle Theorems practice questions. I really hope you found this video useful. If you need any extra help on Circle Theorems, if you go to corbettmaths.com/contents and scroll down to videos 64 and 65, there's video tutorials there on Circle Theorems. Alternatively, you could scan this QR code. But in this video, we're focused on the video solutions to the practice questions. So I really hope you found this video useful. And if you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.